Good morning, everyone. I'd like to welcome you to our first annual MPS Day, which is an outreach program that we're sort of starting with local community colleges and junior colleges around the state. And you'll hear from me later. I'm Matt Augustine. I'm the MC for this event to make sure everything goes hopefully smoothly up here on this end. I'm a faculty assistant to our first speaker, Professor Dean Navratsky, and she's going to tell us a little bit about what the Division of Mathematical and Physical Sciences does here at Davis and what our mission is, and a little bit about the division in general within the College of Letters and Science. We're going to then move, as she's on her way. Come on up here, Alex, if you want to. I'm just going to keep talking while you make your entrance. After Alex makes a few comments, we're going to move on and we're going to have short 5-minute presentations from the various departments in math and physical sciences. We're going to talk a little bit about graduate studies. We're going to talk a little bit about undergraduate research. And then we're going to break into a session where we give you all information about what it's like to be here at UC Davis. Professor Navratsky.
Well, thank you, MCMA. It's a pleasure to welcome you to the first of what we hope will be many events like this. Let me perhaps first introduce a few people. Matt, obviously. We have a wonderful organization called AMPS, Ambassadors of MPS, that started, 2.5 years ago, and it is the undergraduates who are really intent on helping each other, helping you, publicizing MPS, and simply doing fun things together. So will all the AMPs please stand up? We also have some of our undergraduate and graduate students here. If you didn't stand with the first group, please stand up. Okay. We have our wonderful undergraduate advising team from MPS. Please stand up. And then we have you, the visitors. Please stand up. So this is really a mix and match event. Can we provide something of use, of interest, of fun for a wide variety of people? And we think we can. So let me tell you a little bit about myself. My name is Alex Navratsky. I have been at Davis now for just about 20 years. Before that, I was on the faculty at Princeton. Before that, on the faculty at Arizona State. My undergraduate and graduate education are in chemistry, physical chemistry from the University of Chicago, and I'm originally from New York. So I've had a long career, and basically right now I am wearing a number of hats. I am an active researcher with a group of about 30 people, postdoctoral visitors, graduate students, undergrads, technical people, etc. We study the thermodynamics of solid materials to understand both how they're compatible with each other and potentially in devices, but more importantly to understand what makes them stable, what their bonding is. So we have a large research group. I am also interim dean of the Division of Mathematical and Physical Sciences in the College of Letters and Science. What the devil does that mean? I really wasn't quite sure of it myself when I started 3.5 years ago. I'm still not quite sure of it, but the organization of the university basically is that one breaks up the university into a number of colleges, so College of Agriculture, College of Letters and Science, College of Engineering, for us, College of Biological Sciences, which is sort of a Davis peculiarity. In many other universities, biological sciences and the rest of science are together. Here, we're separate for a bunch of historical reasons, etc. Within those colleges, in some cases, there are divisions. So within Letters and Science, which is the largest college on campus, both in terms of student numbers and faculty numbers. We have HARCS, Humanities, Arts, and Cultural Studies as a division, Social Sciences as a division, and Mathematical and Physical Sciences as a division. And really, because we do such different things, ranging from music to Islamic studies to particle physics to economics, we really are organized in groupings that are, at least have something perhaps more in common within each of the divisions. So what does a dean do? A lot of paper pushing, of course, because that is required. The university is a big bureaucracy. We interact with the state and the federal bureaucracies, so there's a lot of paper pushing. And there's a lot of paper pushing having to do with hiring faculty, promoting faculty, et cetera, and there is tremendous concern that all of these things be done properly and fairly. But that's not the interesting part of being dean. The interesting part of being dean is looking at the opportunities we have within the departments, and MPS has 5 departments: chemistry, physics, mathematics, statistics, and earth and planetary sciences, and then it has some research unit efforts as well that are sort of separate little organizational things. So we keep busy within these. What I like to do is to get to know the faculty, see what the opportunities are, not just within the departments, but between the departments. And I think bringing new people in, faculty hiring, starting new initiatives, helping the faculty thrive, that's the real job. And of course, the reality is that all of this is money limited. The state has not been generous to the universities. Those of you who pay tuition know darn well the state has not been generous to the universities. But we work within the reality, and we try to do our best. So one of the things that I really enjoy doing is an event like this, which cuts across all the way from young people to more established people, people who are at Davis, people who are contemplating coming to Davis, and really reaching out and saying, in this modern day and age, in this modern world, STEM fields, science, technology, engineering, mathematics, are absolutely essential to the functioning of modern society. But more to the point, they're absolutely fascinating. In a way, one is honored to be at a time where knowledge is expanding, where understanding is expanding and shifting, where there are so many opportunities. Of course, there are challenges. But what I want to basically leave you with is the thought that that there are 2 certainties in the world. The first, the only certain thing is change. And you will not have, what the world will look like in 10 years or 30 years or 50 years or more is going to be very different from what it is now, and it's fundamentally unpredictable. So you have to accept and indeed thrive on change. The second, and a corollary of that, is that the only thing that is absolutely certain for yourselves is that if you don't try for something, you will not get it. So people say, oh, it's hard to get into college, oh, it's hard to get a grant, oh, but somebody's going to succeed. Why not you? So we're here to help you. We're here to give you a snapshot of all the various wonderful things that are going on here. And we hope that you have a great time. And again, don't hesitate to contact us. You can look up all our various emails. You have some information. Don't hesitate to contact the departments. Don't hesitate to contact the older students, the AMPS people. The most important thing is to really get information and pass information on. So have a great day. Welcome to our first, but certainly not our last, MPS Day at UC Davis. Thank you.
Thank you so much, Alex. That was very inspirational and informative. What we're going to do next is we're going to have quick 5-minute snapshots of the various departments, and we're going to start first with my colleague Jesus Deloria, a professor in mathematics, and he's going to tell us a little bit about what goes on in the math department.
Okay, first of all, welcome everybody. We're delighted to have you here. So again, we are really trying to make a strong effort to communicate with community colleges, CSU, all the junior colleges in the area, because we feel that it's extremely important that we become closer together. And this can only bring good things for the students, which is what we care about, of course. And so I'm here to tell you in a few minutes a snapshot of the math department. You will get a chance to see the math department. If you're a student, you will go see the amazing things that our dual students are doing. But let me say that definitely the math department is, as we say in this brochure, presents extraordinary opportunities for you. It has compelling research, and it has a bright future to bring you. So if you just look at the numbers, we are ranked 33 worldwide among math departments and 24th among US universities. We have 50 faculty that have won so many awards that I'm not going to tell you about them. Amazingly, now we have actually a little bit over 700 students. In 3 different majors, we have mathematics, applied mathematics, and a new major in analytics and operations research. So I hope all of the faculty and the students are wondering, well, what is all this about? And we'll tell you during the day. As far as the graduate program goes, we have over 100 graduate students. You will have opportunity to meet some of them today. And I just want to highlight a few things beyond the numbers, right? Numbers are beautiful, of course, I'm a mathematician, but I would like to talk, so I come to talk to you about people. So let's see, so here's the first highlight of the day. This is Professor Naoki Saito. Some of you will have a chance to meet him today. I think he's going to be here for sure for the meeting with the faculty that we're going to have, and then also for the lunch. So you will get. So this gentleman is an expert on anything related to the mathematics of image processing, information processing. When you have a picture, he may be behind it. When you take a picture with your camera, with your cell phone. So for example, here, I'm highlighting one of his patents. He has, I think, a number of patents, and this is one of the old ones. This is not by far. So when you take an image, there's a lot of information in an image, and the important thing is to compress the image in such a way that you can actually send it via email, for example, or capture it in a file without losing too much information. So he has worked on analysis, using analysis, applied harmonic analysis, which are classes you can take as an undergraduate, like Math 129, to actually provide you with some really cool images like this one, like these crayons. So let's see. Next is, oops, sorry. There it is. There. So we have a large, we are the Aggies, right? So biology, of course, plays a big role on campus, but math biology plays an extraordinarily high role on campus too. So I just want to highlight, again, these are just bits and pieces of what is available to you. So I want to highlight the research of some of my colleagues in the math department, in the math bio team. We have a large group of mathematical biologists that study all kinds of biological systems, from very large animals. For example, how do horses walk? Professor Sam Walcott is one of them. And then you study the really tiny stuff, for example, at the DNA level, Professor Mariel Vasquez. But I'm just highlighting one point here. So, excuse me, a group of my colleagues there study, plaquettes which are in your blood, and they are very important because they transport oxygen in your blood, and they also are important in clotting. When you have a wound, you don't want the blood to get away. Well, it depends on the geometry of the plaquettes. So they have, I don't know if you can see, it's a bit faint, the strange pinch shape of the plaquettes that in the picture. So why do they have this shape? Yeah, that's a natural question, because when you see disease plaquettes, you see that they don't have this shape. So that's understanding. So there's a mathematical model that was published a couple of years ago explaining exactly why the plaquettes have to be this way. So if you actually consider normal conditions of pressure in the blood, they have to be this way. Otherwise, there's a problem. So let's move on to another example because, oops, I'm sorry, going the wrong way here. Yeah. So this is Charlie Bromet, the gentleman that you see in the picture, Charlie Bromet, one of our graduate students. I just want to say that you don't have to be old to do research in mathematics, by no means. This young guy is one of our recent graduates. He was working on networks. So networks you see over there, this is an example of a network. But if you use Google, I mean, tell me who doesn't use Google in this room, right? Everybody uses Google. So you are inherently walking on a network. You're walking on a network where is, there's nodes. Think of a road network or a train network or a social network, people that know each other. So these are everywhere in society, in science. So in the math department, there's a number of people, including myself, that study this kind of thing. I'm running out of time, I know. So let me just conclude by telling you there's all this amazing research. Come talk to us, and the people is the best. So we take care of our students, you see? We love our students with careers and all. So I'm going to give the, thank you.
Thank you so much, Jesus. That was fantastic. Way to kick it off. Our next speaker is David Whitman from the physics department.
All right, I'm really excited to talk about the physics department. It's just a vibrant, wonderful place to be if you're interested in figuring out how the universe works. And that's in large part due to our excellent faculty. So we have 50 faculty members, and their research spans the entire range of physics from the smallest things in the universe to the largest things in the universe, which we have a picture of here. And also our students, we have about 170 graduate students and about an equal number of undergraduate majors, and we're ranked in the top 30 of physics departments nationally. So I'm just going to give you a very quick overview of each of the main research areas. So we'll start with astrophysics and cosmology, and I put this picture actually on the title slide because we may not think of this as part of physics, but it really is. So astronomy or astrophysics is just physics applied to the rest of the universe. And this is an area that our department has pushed into a lot over the last 10 years. So we now have 10 faculty members in astrophysics and cosmology. And it's definitely an integral, one of the core parts of the department now. So you can ask me about what this image means later. So it's a picture of dark matter in a colliding galaxy cluster. We have access to one of the best telescopes in the world, the Keck telescopes. There's a picture of here. And we've also been very successful in competing for grants of time on the Hubble Space Telescope. And UC Davis is also one of the leading partners in an international collaboration to build an amazing new telescope called the Large Synoptic Survey Telescope. There's a drawing there. It hasn't been built yet, but the building is already being built. And this telescope has a very wide field. It can survey the entire sky of the southern hemisphere where it will be based over and over again. So we'll open up what we call the time domain, seeing how things change in the sky, as well as being able to see extremely faint things. And I also want to point out that we have faculty members who are experts on the cosmic microwave background. You may have heard of that, the Planck satellite. So you may have seen a press release where this is called a baby picture of the universe, and we have experts on that as well. Now, one of the great things about physics and science in general is that everything is connected. So these are some of the largest systems in the universe, but their properties are really determined by some of the smallest things in the universe. So, for example, the cross-sections of nuclear reactions that happen in the sun determine how much energy the sun gives off, and therefore its size and temperature and so on. So one of the great things about our department is there's a lot of connections between different research groups. So when you think about physics, you probably think about this. This may be the picture you have in your mind. This is the CMS experiment at the LHC, where they famously found the Higgs boson. And in fact, one of our faculty members wrote a book way back in 1990 called The Higgs Hunter's Guide. And so a lot of our faculty have been instrumental in finding the Higgs. But that's not all of particle physics. So there's a variety of other contexts where you can apply, where you look at particle interactions. So this is a picture of the LUX experiment, which is looking for dark matter particles that come to Earth. And this container will be full of liquid xenon, and then the surrounding area is a shield. And so I showed you a very zoomed out picture of dark matter in the previous one. So this is looking for specific dark matter particle interactions to figure out what kind of particle dark matter is. Here's another neat example of studying neutrinos. So this is an experiment called DUNE, where neutrinos will be made at Fermilab and sent several hundred miles underground to an underground facility in South Dakota to study the mixing angle between neutrino flavors. And we also have faculty who work at the Relativistic Heavy Ion Collider, where they, at the LHC, they smash together protons, but at RIC, they smash together very heavy nuclei like gold, and therefore they can create very dense conditions and study quark gluon plasmas. Speaking of dense conditions and condensed matter, so condensed matter is what you see around you every day. In everyday systems, we can't study particles in isolation. They interact with each other a lot, and we can get emergent behavior. So we have faculty studying nanostructures, optoelectronics, strongly correlated materials, surfaces. So surfaces are a place where, because things are confined to 2 dimensions, you get very different types of behavior. And this is where, all the devices that you rely on every day operate on physical principles that condensed matter physicists have figured out. And we also have experts on making those materials. Now, if you're thinking about complex interacting things and emergent behavior, what better place to apply that than in biophysics, biological systems? So we have a smaller number of faculty, but still, there's no boundary between condensed matter and biophysics, really. So we have a faculty member, Dan Cox, who may be here later today, who is actually part of a consortium that studies the brain. And this image here is from Professor Rundle, who works, he's also got a joint appointment with geology, so he works on earthquakes and earthquake prediction. And we also have faculty who study the physics of networks. That makes a good connection to the mathematical study of networks that Jose mentioned. And I would be remiss if I didn't mention also the physics education effort. So in the last few decades, physicists have realized that they're uniquely positioned to study scientifically how people learn physics. And we shouldn't just leave that to education schools. And so we actually have scientific research into how people learn physics and how to design curricula better. And that's an important part of what we do because we really care about education. I've really focused on research here because I'm guessing that's what you came to see, but we also love education and we really care about our students too. And the physics department is a great place to study the universe. Thank you.
All right, our next speaker is Annalise Franz. She's a professor in the chemistry department, and she's going to share a little bit about what we do in that department.
All right, thank you. I get the now next whirlwind tour, and I'm going to tell you briefly about chemistry. So we have a pretty large program that obviously includes undergraduate and graduate students. We have 44 research faculty in the department, and we also have a large number of very new, young, and enthusiastic faculty, which is always great for interacting with students. We also have additional members of a chemistry graduate group, so you can also come and either take classes or work in research labs with faculty in biomedical engineering or across other areas of campus biology. So it's a nice opportunity to think about applied chemistry, not only in the chemistry department, but without. And then that in total gives you at least 53 total mentors in terms of as research for undergraduate and graduate students. We have 260 graduate students and more than 800 chemistry majors. So we do have a variety of chemistry majors for the undergraduates, so all the transfer students out there who might be thinking about these, this is a nice opportunity to also see how we focus a lot on applied chemistry in terms of pharmaceutical chemistry, chemical physics, environmental chemistry, and forensic chemistry. For our chemistry PhD programs, we fall very much within the classic lines with inorganic, organic, chemical biology, analytical, physical, and chemical physics. At least that's what we write on our website. But really, when you go, you'll see faculty listed in multiple areas because the research areas are very applied and interdisciplinary. And I always like to remind people, because I know that some people don't actually appreciate how much money you get paid to come to graduate school. All right, so there's advantages here. It's not just for your benefit, but because you're serving as a TA and participating in research, you will get research funds and stipend and tuition reimbursement. So I am not focusing quite as much on the research. I wanted to gloss over that only to also show you a lot of great pictures of what's going on in the department. But we have a lot of funding within the department that ranges from areas of biology, chemistry, applications in engineering, materials, alternative energy. So specifically the areas that we put a lot of emphasis on are the areas of applied chemistry, as well as developing equipment and features associated with analytical and physical chemistry. So I've just highlighted a few examples: medicinal compounds, materials for energy solutions, computational drug design, protein engineering and synthetic biology, biofuel production, and enzyme mechanism of DNA repair, for just a very few examples. We have a lot of great facilities, which many of you on tours will see some of today, including our labs. These are not only in the chemistry department, but across the campus. There's also central facilities that are shared by multiple departments, which gives you expertise and opportunities for collaborations. Award-winning faculty, the main reason to show this is all the smiling faculty faces. They don't just smile because they win awards, but they win awards because they are passionate about their research and working with students. And this includes a lot of mentoring awards as well. And then where do our undergraduates go? All the classic places. Here's kind of one of maybe the best slides because it shows it in a visual way. You'll recognize a lot of the names of companies where students, our undergraduates go, our graduate students go. This includes both jobs as well as some opportunities for summer internships. And so we like to think this also represents the diversity of applied chemistry that you can be involved with. And of course, we have a lot of fun. So one of the things we do, the ambassadors might recognize a few faces. This is from the recent Halloween party and the costume contest that took place. And there's some great creative costumes. My favorite one are the linked DNA pairs to the t-shirts. And then I won't read the quotes, but we've got several of our fabulous students here to share their experiences with you directly. So hopefully my 5 minutes merely catalyzes your passion a little bit more, and we'll see you more at our Q&A panel today. You'll be able to talk with students on the lab tours and during lunch, and ask me any questions you might have. Thanks.
Thank you very much, Annalise. Our next speaker is Wolfgang, and he is going to tell us a little bit about some work in statistics. I leave the floor to you, sir.
Thank you. Hello, everyone. Welcome to this first MPS day. So my slides on statistics are a little less flashy than the other ones. This doesn't mean that our research and our department is less interesting, but so let me just say a few words about the department, and I'll tell you a little more about myself. So we have currently 20 faculty in statistics, and maybe I should emphasize that statistics is an independent department. So if I talk to people in the public, they often are still surprised that there is statistics as an independent entity, not related to math. So we have our own degrees and our own department and so on. So we have 20 faculty and we are growing. So we have been well known and ranked very highly in the top 30 for sure in the state in many mainstream areas of statistics. And so the great thing in statistics is that many of our faculty are actually collaborating with all what you heard today already. So this includes astrostatistics, image analysis, neurosciences, statistical computing, machine learning, including network analysis, and so on. So all this is somehow done in the department. So we have a huge number of, very large number of collaborations with other departments. I list some of them here. So this is what our faculty are doing outside of the core research of statistics. So I would consider myself more a researcher contributing to the core of statistics, but there is much research as well done in collaboration with other departments. At this point, we are moving towards building up more strengths in machine learning. So our recent hires were all in this area. And we were hiring quite a number of people in recent years. So let me say a few words about our undergraduate program. So we have 3 emphases: general statistics, applied statistics, and computational statistics. We have currently about 450 majors, which is, I think, a huge number, even if you consider, compare it to other departments in the state. So it's probably one of the top, the largest departments out there. Our graduate program, we have masters and PhDs in statistics. We have a small sub-track, it's a PhD with an emphasis in biostatistics. Currently about 100 graduate students, roughly split half and half in masters and PhDs. And we are also housing the PhD in biostatistics. So this is an independent graduate program. It doesn't really belong to statistics, just like applied math doesn't really belong to mathematics, but the math department is running the applied math program, and similarly the statistics department is running also the biostatistics graduate program. So we teach many of the core courses, and all the biostatistics students are in our housed in, most of them are housed in our building, so they're together with the statistics students. Then I probably should also mention that we have a hybrid program. It's called IDP, Integrated Degree Program. It's a 4+1 type degree, so you have 4 years for your undergrad, and then you can add 1 more year to get your master's program. So this is called IDP. And students after, in their 3rd year can apply for that if their performance is, so we look for good students who then are admitted to the master's program. And last but not least, I'm quite proud to be the director of a large research training grant sponsored by the NSF. So the NSF gave us $2 million just for doing statistics education and training of undergraduate and graduate students and postdocs. So that's the end of my slideshow. So let me just say a few words about myself. So I came to Davis maybe 18 years ago or so with my family. My son is now in graduate school. He went back to Germany, believe it or not. And so my research is more on the mathematical side, but I do also interesting research in network analysis, functional data analysis, and more recently also in topological data analysis. So this intersects with the math department and with all the other departments here, more or less, and I think this is one of the great strengths here at UC Davis, that there's so much interaction going on and overlap, which makes it really interesting to be here. I at least feel so. Thank you.
Last but not least, Professor Isabel Montañez from Earth and Physical Sciences. I'm a chemistry major, but I wish I'd have been a geologist. Yes, I love these kinds of talks. So without further ado, I yield the floor to Professor Montañez. I hope. Yay. There you go.
All right.
I'll be ready to help you with your video.
Oh, I think I can do
I
that.
know, it's all messed up.
Okay, I'm here to give you the last of the 5 whirlwind tours and to give you a sense of how we integrate our research and teaching mission in the Earth and Planetary Science Department, as well as the broad scope of opportunities that we offer to our students. So we have 23 faculty, quite a few additional research faculty, research associates I would call them, and 98 undergraduate majors, 43 graduate students, and we offer, in addition to our traditional geology major, 3 others, as well as 6 minors. And I'll say a little bit about that in a few slides. So it's probably good that we went last because we in EPS are basically a good representation of the math and physical sciences. We're basically a bunch of chemists, physicists, biologists, mathematicians. And we apply the principles and concepts of these fields to the study of the Earth and as well as other planets. There is one difference. We like to do much of this outside. So we offer a community that really appreciates the opportunity to teach and to do research within a really personal relationship interactions that provide the student an opportunity not just to do research and to learn, but also to develop career skills that are probably fairly interdisciplinary. And whether this is in the field or the lab, and in the field, this research often covers all 7 continents. So we have our faculty offer teaching and research expertise in a broad spectrum of subdisciplines. Undergraduate and graduate students are involved in almost all of this research. So I'm going to just give you a quick overview of our sort of subdisciplines that we represent. Our paleoceanographers study things like ocean acidification and past and future climate impact on everything from the coastal regions of California to the deep oceans throughout the world. They're affiliated with the Bodega Marine Lab, which is an excellent facility in the UC system. Our biologists or paleobiologists study fossil organisms to look at the history of life and also the interactions and responses and feedbacks of life's changes with the environment. Our geochemists are quite diverse. They use a vast array of our analytical facilities, some that you see here, 2 which will be shown on our tour today. This vast array of facilities to probe the Earth from the very deepest mantle to the diverse environments on our surface, to look at the age of the Earth, the age of the solar system, to address things like climate change, past and current to future. Our planetary faculty are interested in also in a vast array of topics, things like meteorites, cosmochemistry, whether it's in remote regions or even in our backyard. This is the Sutter Hill meteorite that fell a couple of years ago. And studying things like impacts. The gun lab that you see here will be on the tour as well. So impacts, formation of the moon, and other issues related to the solar system. So many of our faculty use mathematical and computer codes coupled with things like remote sensing, whether it's by airplane or by satellite or even by rovers. To look at the development and evolution of landscapes across our planet, as well as in other planets. And all of this, as you can see from our 3D visualization cave, can be done without leaving the comfort of our building. So I want to stress that in all of these, I think you've seen in the pictures, in all of these research areas, the students are a critical component of that work. So we offer 4 majors, the traditional geology major, as well as the ones listed here, but 2 of these are new majors, and they are interdisciplinary and cross-college. That is the marine and coastal science major and the earth system science major. We have 6 minors listed here, and I don't see, oh, there we go, 6 minors listed here, ranging from engineering geology, environmental geology, geophysics, and so on. And our graduates successfully go on to graduate programs all over the world, go into geotech, mining, and petroleum industry positions. Quite a few are now going into things like science communication and policy development associated with NGOs and government offices. And in the last 30 seconds I have, I'm going to share with you a video that is from a current, or excuse me, from a recent graduate class field trip. And if anybody has any questions, I'll be happy to answer those while you watch the video.
And I take that class too?
See, I told you, I wanted to be a geologist.
Yeah, we're all physicists and chemists, biologists, mathematicians. Do we have, I can't tell from the way the seating was, whether we actually have some geoscience, earth science people in the audience.
Is there anyone interested in geology?
Or wannabes?
Wannabes?
Okay.
Okay, thank you, Isabel. Okay, that concludes our sort of fast whirlwind tour of the various departments that we have here in Math and Physical Sciences. The next thing we have is a little activity that Professor Franz has developed, and she's going to tell us a little bit about that. So I now yield the floor to her.
All right, well, it's a pretty short activity, and we're going to shorten it a little bit. But the goal is, now that you've heard us talk, is to be able to talk to people at your table and meet them and be challenged, and let's say in 4 minutes, how many things can you find in common with the people at your table? And saying that everyone has eyeballs doesn't count, all right? No body parts. All right, so see how many things you can find, and then we'll see what's the most interesting thing in this room that your table might have in common. So I'm hoping, like, for example, if everyone's been to Antarctica, that would be really cool, okay? So you have 4 minutes. That's your challenge. Go. That concludes your fabulous 4 minutes. Which table thinks they have the best thing in common? Oh, what? Okay, this table all likes to hike. Anyone have something they want to? That's a great one. And any other table think they want to? Anything cool your table has in common? Yeah, back there. They've all traveled out of the country. Awesome. All right, but not to Antarctica. All right, what else? Yeah, over here? They all speak, that table all speaks 2 or more languages. Cool. Oh, yeah. And at first they said, I heard them say, well, the thing we have in common is we don't have anything in common. I was like, I know that's not true. All right, one more. Any other table? Yeah. Oh, that table, no one was born in California. All right, and I think we all know that everybody in this room also has one thing in common. You all love MPS Day, right? All right, thanks. Okay, and so now we're going to turn it over. Do you want me to? Matt will give you.
All right, next speaker, Stephen Lee, where are you? There he is. He's going to tell us a little bit about graduate studies here at UC Davis. That's laser.
Okay, cool. Well, welcome all. Thank you all for coming. We're glad whether you're a student or staff here at UC Davis or if you're visiting, thank you all for coming here. So this is the first event that we're thinking about making an annual event. So we hope that you'll enjoy it, and we hope that you'll come back and encourage your other friends and colleagues to also return in the future. So I want to explain a little bit about the Office of Graduate Studies. So that's the office that I come from. But I also want to give you a little bit of an overview of the university. So obviously you're here at Davis, which is shown on the left-hand side. But we also have other different sites for the university. So on the far left, we actually have a marine laboratory at Bodega Bay. And so there's some of those who are studying ecology and marine sciences are on the coast. And then obviously there's Davis. And then further along the line, we also have a site in Sacramento. So many of the folks in medical sciences, or there's a hospital there also in Sacramento. But we also have a research center in Tahoe. So we actually have different sites spread throughout Northern California. So hopefully you get a chance to explore the other sites also for UC Davis. We've got about 35,000 students currently enrolled here on campus. That's all the undergrad, professional, graduate students, and so forth. But we also have among those 35,000, we've got about 7,000 of those students are graduate and professional students. And so we hope that many of you, or all of you, have become graduate students here at UC Davis too. Okay. Some rankings and distinctions among public institutions all throughout the U.S. We're ranked around 11. We were 9th in terms of having connections with international scholars, so we actually have a significant international community here on campus. We're first in the world, often considered for our vet school, and so even though you may not be considering vet school for yourself, that also has a lot of connections for those who are interested in studying animal sciences and behavior and so forth too. We're also considered one of the best in terms of for faculty writing papers in ecology and environment, so anything related to agriculture, ecology, and so forth, that's one of our main strengths too. And so agriculture and forestry also we're often considered very high. So any type of those type of connections, even though you might not be studying agriculture yourself specifically, but there's also many of the programs and research interests will often overlap with those fields too. Okay. I hope you get a chance to explore the whole town of Davis too. We are definitely a college town. We're kind of quirky and unique in many ways because we are a college town. We have a farmer's market, so if you're interested in natural and organic foods, there's many other people who are really interested in that. We've got a wonderful farmer's market. Many people here on campus bike, and so if you, it's really wonderful to see a campus around noon where you actually have almost traffic jams for bicycles who are biking around campus, and so it's really wonderful to see all the bicyclists around campus too. Okay, so there's lots more information on our Davis Wiki site too, so if you want to explore a little bit more about the whole town of Davis, it's really wonderful to explore the whole town. Okay. In terms of leadership of graduate studies, the dean, Prasad Mohapatra, is the dean of the Office of Graduate Studies. Unfortunately, he couldn't come here this morning because he's got meetings in Sacramento, but hopefully get a chance to connect with him at some point too. Okay. So I also want to explain a couple of other people. This is my mugshot on the right-hand side. So I'm Steve. So I'm what they call the Graduate Diversity Officer for the STEM disciplines. Lynn Archangel, many of you communicated with her too. She's also wonderful. She coordinates on the UC Leads program. So if you're part of the UC system, you may be interested in participating in that as an undergraduate. She's also very involved with our professional development activities and also in terms of our diversity efforts too. So if you didn't get a chance to thank Lynn, Lynn is at the registration table. Lynn did a lot of the heavy lifting and so forth in terms of coordination of this. So be nice to her, okay? So she's the one that controls a lot of stuff. So be nice to her. If you get a chance on your way out or whatever, say thank you for her. She did a lot in terms of coordination of the food and activities and the scheduling and the program for today. So please thank her for her efforts too, okay? So because Lynn and I are also very interested in professional development, I also want to very quickly mention our Grad Pathways seminar series. This is actually a nationally recognized program to help train graduate and professional students here on campus. And so lots of universities have graduate schools and graduate programs and so forth. But we actually want to help you succeed not only in graduate degrees, but also in gaining your professional skills too. So Grad Pathways is nationally recognized. A lot of other universities actually look to UC Davis in terms of what we do for the Grad Pathways. So there's lots of activities through the Grad Pathways program. So there's different 8 competencies that we help you to focus on and develop during your graduate program too. So we want you to achieve and earn your graduate degree, but we also want to help you develop your professional skills because that's really critical for your next steps and in terms of your employment too. Okay, and I think that's it. So thank you very much.
All right, I believe our next speaker is again Annalise. If Annalise, oh, there she is. Good. And she's going to tell us a little bit about undergraduate research here on campus.
All right, well, I don't wear quite as many hats as our dean, but in addition to serving as the chemistry faculty member, I also am the faculty director for the Undergraduate Research Center. And I know we have undergraduate students who are thinking about potentially transferring here or currently thinking about graduate school. So I wanted to just briefly emphasize the opportunities for undergraduate research at UC Davis. And this is across all areas and all departments. And whether you are either the transfer student looking for an opportunity or someone knowing that when you get here, undergraduate students are valued and you will be able to mentor them as part of your graduate training. Essentially, what does undergraduate research look like? Well, it's actually quite diverse depending on the research area. As you've heard, there are many departments and different research opportunities, even in MPS. But we have field work, we have agricultural collaborations with engineering, collaborations with marine and geology, different opportunities with computational and data analysis, and then actually travel all over the world. So, of course, you may have seen research prior to here, but we have so many opportunities on campus here, and undergraduate or graduate students are typically involved in all of them. Approximately 70% of all UC Davis undergraduate students participate in research, and many of these are in their junior and senior year. So if you're coming in as a transfer student, it's perfect timing. Many of you may also know some of the benefits already, but just a quick summary. Earn credits toward your degree if you're pursuing undergraduate research. Whoa, trigger there. We have a bunch of awesome instrumentation that you would learn how to use, lab experiences beyond coursework, applying your knowledge to real-world examples, developing communication and writing skills. So even if you don't continue in lab or intensive research areas, those skills will be extremely valuable. Also, this really helps you understand what do you want to do potentially after you graduate. Obviously, it looks great on your resume, valuable opportunities for presentations and publications, and then you're going to be more competitive for programs that you continue on to. And the one that's not on there, that's one of the most important ones, is that you will have fun. Okay. And then through the opportunities specifically designed for undergraduate students, we have a lot of awards, fellowships, opportunities. We have conferences on campus and various special undergraduate programs. Specifically, we also try to encourage undergraduate students and graduate students to present their research, conferences on campus, as well as national and regional conferences in the area that specialize in their research area. We have a fabulous undergraduate research center, and this provides a lot of resources to either partner undergraduate students with faculty and graduate student mentors, or also just to provide amazing research informational sessions, workshops, abstract writing, aspects like that. And there's a website where you can learn more information. Regarding those special undergraduate research programs, especially if you're coming in as a transfer student, we have fabulous opportunities for NSF REU programs. On campus, once you're a student here, we have various programs like the Beckman Scholars Program, the VIP program, McNair, Camp, MERPS, Murals. Everyone has their fun acronym. But basically, these are programs that provide you with numerous opportunities, not only for research, but also professional development. One quick quote, because you shouldn't just take my word for it. If you're a transfer student, here's another transfer student's perspective. Joining a research lab here at Davis proved to be one of the best decisions I've made for many reasons, et cetera, et cetera. And basically, doing research was also instrumental in solidifying my decision to go to graduate school was something I hadn't even considered prior to transferring. So whether you're here as a transfer student or whether you're here knowing that you're interested in graduate school, these types of research opportunities are fabulous. For more information, you can go on the lab tours today to see firsthand some of what's going on, talk to the faculty and graduate students here today, and also talk to our undergraduate advisors, and go check out information on the Undergraduate Research Center website. Thank you.
All right, I am the last speaker of the morning. We're about 15 minutes behind schedule, so I'm going to be super brief. Clearly what you all saw today was a lot of research, a lot of flash in our various departments trying to download to you in 5 minutes all the exciting things that we do. And one of the things that should be coming out of that is that the UC system, and UC Davis in particular, is a research university. It gives you this opportunity to get into labs. And so while you're learning and doing the sort of traditional book learning, you also have the opportunity to do fascinating, interesting, state-of-the-art research. That's not what I'm going to talk about today. One of the things that you need to also get out of this day, and I hope that some of you are interested, are some more details about the dynamics of what it's like to be an undergraduate here on campus and what it is if you're a transfer student and you want to succeed. What are some of the key things that you need to learn from that? And we're going to be drifting more into those sorts of details throughout the day, although we have lab tours coming up next. After that, we're going to talk about some various aspects of what it's like to get a degree here on this campus. And so I hope that you all have an appreciation for what we do a little bit here in math and physical sciences. You heard about our different majors. We have 14 different majors in 6 departments, and you heard from virtually all of them. And transfer students and incoming graduate students are a critical part for this program. You transfer students enrich our campus, and you bring us immense value, and you're a community of innovators, right? Your experience, like when I'm in the lab and I'm working with my students, I tend to just let them go because they will discover things that maybe my sort of parochial upbringing and channeling into a certain area I would not have considered. I can't tell you how many projects in the lab have actually stemmed from undergraduates' ideas, and it's very fascinating to see that. Now, as I said, some of you are here to learn more about the programs and get insight on how to be a successful transfer applicant. But the application is just the first step, or I should say this is the pre-step being here. The next step would be the application. So one of the roles that we have, although we've been advertising so much about research, is to give you information about what it's like to be a successful transfer applicant, not just successful in the application process, but successful in terms of coming here, taking the appropriate classes, graduating in a timely fashion 2 years after you get here if you're a transfer student or earlier. And that's kind of difficult to navigate those sorts of paths, and we're going to give you some clues on how to do that. This is further complicated by the fact that here at UC Davis, we're not on a semester system, we're on a quarter system. As an instructor, I personally love the quarter system because right when you're just about bored with the material, after teaching it for like the 15th or 16th time, you're going down the hill into finals week. And so it's really fun from an instructor point of view, but it can seem very, very fast from the student's point of view, because you're essentially taking the content of a semester and compressing it into a quarter. So it's a super fast system, and it may take you a little while to get used to that. One of the questions that you should be really, I'm sort of saying this over and over up here, is how do you best prepare yourself to be a successful transfer applicant or student? And I think all of the faculty in this room, or all the UC Davis representatives, including our ambassadors, including the undergraduate and graduate students in the room, and since you're a graduate student, most of the times you're a teaching assistant, and so you can see this in the students when you're teaching, is preparation. This means that when you come to campus, the best thing that you can do before you get to this campus is make sure all of the prerequisite courses and background courses that you need to take, you have taken. Because if you come here to campus, a lot of those undergraduate courses are already populated by students and they're not available. And what's going to happen is you're going to incur delays. And when you incur delays in terms of class availability, because you haven't had all of your prerequisites knocked out, that's going to lead to extended time to degree, which means paying for yet another year of a college education, which is unfortunate. So if you plan to apply, for example, to this campus as a chemistry major, you got to make sure that if you want to be a chemistry major, that you have all of your general chemistry out of the way. So it's kind of a problem if you're coming here as a junior and you've never had general chemistry. And that's one of our key bottleneck courses on this campus. Last fall, for example, we taught 6 sections of general chemistry, intro general chemistry, 550 students per pop, and there was still not enough room. So make sure you get all those prerequisites out of the way. So if you want to be a chemist, you would take general chemistry, you would take calculus, you would take organic chemistry, everything that would be in our curriculum below the junior level. I'm sure there are if you look at the other departments, there are other requirements that are going to be there for being a successful transfer student. You're going to meet today throughout all of your tours. You're going to meet all of us various faculty, not just the faculty that are here, but faculty that I've seen here in the back of the room that have come in and have already drifted out to their departments waiting to see you on your tours. I encourage you all to familiarize yourself, introduce yourselves to us. We're here for you today so that you can learn how to be a successful transfer applicant, so that you can learn how to be a successful graduate student, so that you can learn how to come into our programs because we want you. It's not just the faculty that you can talk to our ambassadors of MPS who are here. Our advisors are here in the back of the room. We're all here to give you advice, and please, please don't be afraid to ask questions because we want you to succeed when you come to this campus. We're excited to have you all here today. I'm going to stop because now we're 20 minutes behind schedule, and I think what should I hand it off to you, Manny, or should I just divide up right now? Yeah, come on up here. Mani Tripathi. He is a professor in physics. He's my counterpart, faculty assistant to Dean Navratsky and MPS in terms of he does graduate education stuff. And it was his idea to put this whole day together. So we thank him for that. And I give him the floor.
No, I just want to let people know that the faculty should stay here and the students should pick one of the 4 tours that they want to be part of. So can the AMP stand up, whoever is leading them to, yeah. So why don't we just sort of do it like that? We math here, math and stat here, physics there, chemistry there, and EPS there.